Before you have a go at the exercise, it's worth looking at some general formulas which relate to the modulus and argument of a complex number. So let's say that we've got a complex number and let's call it z, and it's got a real part which is x and an imaginary part which is y. So it's represented by the coordinate x, y. So we've got our complex number there. Well, if you wanted to find a general expression for the modulus, that's quite easy because we can just use Pythagoras on this right angle triangle that I've drawn there. So I know that the length of that line, the length of the position vector going to that coordinate x, y, is going to be the modulus of z, which is the square root of x squared plus y squared, just using Pythagoras. And that's a really useful formula, which we're going to use quite a lot in the next few exercises. Another formula which can be quite useful is a formula which is related to the argument. If we know that the argument of the complex number is theta, so argz equals theta, then we know that tan theta is equal to, if you look at this triangle, opposite the angle theta is the length y and adjacent is the length x. So in general, tan theta is equal to y over x, where y is the imaginary part and x is the real part of the complex number. So that's also a really useful formula which we'll use later on. You've got to be really careful when you use this formula though. Notice that I haven't said, what I've not said is that theta is just equal to inverse tan or arctan of y over x. That's because this equation here has two solutions in the principal argument range between minus pi and pi. If you think about the tan graph, if we know that tan theta equals some value, then there's always going to be two solutions in the range minus pi up to pi, which is the principal argument. So you've got to be really careful if you use this formula. To give you an example of that, let's think about a specific example. Let's say we had the complex number z equals minus 1 plus root 3i. So let's sketch that in the Argand diagram. Sorry, that should be real and imaginary. Then we've got this complex number minus 1 and then root 3 up. So we've got this complex number here. Well, if we wanted to find the argument, what we would have done so far is we would have just said, well, we want this angle here, which is our argument, so let's call that theta. And to find that, what we're going to do first is we're going to find this angle, which let's say is alpha, and we're going to use this right angle triangle to find alpha. So we'll just say that tan alpha, if we find alpha first, is the opposite side length. The opposite side length, opposite alpha in this right angle triangle is root 3. And the adjacent side length in this right angle triangle is length 1. So you'd find that alpha is pi over 3. And then obviously you can find theta, which is the argument of the complex number. And theta would be pi minus pi over 3. So you can find that orange angle, which is 2 pi over 3. And we just check, is that argument positive? Yes, it is, because we've moved around in the positive direction. So we'd say that the argument of this complex number is equal to 2 pi over 3. Fine. If you were to use this formula, the argument, tan of the argument equals the imaginary part divided by the real part, then we would have tan of theta equals y over x, where y is the imaginary part, so root 3, divided by the real part, which is minus 1. That's the imaginary part, that's the real part. And if you just typed into your calculator theta equals inverse tan of root 3 over minus 1, then actually your calculator will give you an answer of minus pi over 3. Now that's happening because if you go to the tan graph and we look at tan theta equals minus root 3, that's what this is equal to, so we're at minus root 3, then your calculator gives you the answer for the angle between minus pi over 2 and pi over 2. Well, actually, we know that the argument of this complex number is positive, so we want this solution, which is 180 more than the solution that your calculator gives you. So you need to take the solution that your calculator gave you of minus pi over 3, and we need to add on pi to get 2 pi over 3. So here we'd have to say that argument of z equals minus pi over 3 plus pi to get you the answer of 2 pi over 3. So just be really careful when you use this formula because you've got to make sure it makes sense with the diagram given in the Argand diagram.